Welcome to the session on how to construct a binary tree on the basis of tree traversal. So let us construct a binary tree given the in-order and post-order traversals. Here are the nodes for in-order and post-order, and in order to construct a binary tree we have to first remember two steps. The first step is to find the root node. So without the root you cannot construct a tree. So finding the root in case of pre-order and post-order traversal is easy. In case of pre-order traversal, the first node is always the root node, and in case of post-order traversal, the last node is the root node. After knowing the root node, the next step is to find the left and right subtrees. That can be found with the help of the in-order traversal, which gives the left and right subtrees. So, before going to that, we should remember how the traversing techniques takes place in in-order, pre-order and post-order traversals. So, as you know, pre-order will have the root as the first node and post-order will have the root as the last node. So, if you know the root, the in-order will give the left and right subtrees. So, having this in mind, we shall proceed to construct a binary tree. So, in post order, the last node is A. So, A is treated as the root node. So, after finding the root node, we will come to the in order traversal where the left of A, the nodes are treated to be the left subtree, and to the right of A, all the nodes are treated as the right subtree. So, this is how we find the root node and find the left and right subtrees. So continuing with the same tree, we are going to now check with the left subtree where DGB. When we go see the post order, B is the last node. So that will be treated as the root node. But to the left of B we have D and G. So to the left of B you will have D and G. In case of HEICF, if we see the post order, C is the last node, so that is treated as the root node. And when we compare it in order, to the left of C we have H, E and I. So H, E and I is to the left, and to the right of C you have F. Next, now we have to go for D and G. When you see the post order, D is the root. D is the last node and D will be considered as the root node, and when we see it in order, to the right of D we have G, so right of D we will have G. With H, E and I, when we see in post order, E is the last node, so that will be treated as the root node. So E will be the root node, and to the left of E we have H in order, and to the right of E we have I. So this is how we construct a binary tree from the given post order and in order. Let us take one more example with pre-order and in order. Whatever may be the case, post order, in order they will give, or pre-order and in order. So in all the cases they will give in order, but you will have a combination of post order and pre-order. So this is an example of nodes with pre-order and in order. So this is just an example. I will explain you how it is done. So in case of pre-order, the first node is always the root node, and knowing the root node we can find the left and right subtrees using the in order. So G is the first node here, and to the left of G whatever comes is the left subtree, and to the right of G is the right subtree. So just see how it is getting constructed. So QBKCFA is to the left of G, so this is the left subtree and the remaining are right subtree. So G will have here if I see QB, here B is the first node in case of pre-order and B will be the root node. When I check it with in order, to the left of B we have Q. So we will have Q. And to the right of B we have KC and FA. KC and FA. Next you have P, because when we see the pre-order, after this P, P, E, D, H, R, P comes first. So P is treated as the first node. And when we check it with the in order, to the left of P already G is over. To the right of P we have E, D, H and R. Next, we have to see K, C, F and A. KC, KCFA. So A comes first in the pre-order. So A is the root node. And when we see the in order, to the left of A, we have F. So F, C and K comes to the left of A, and to the P will have again, it is compared with so D, EDHR, when it is seen in its pre-order, D comes first, so D will be treated as the root node. But when it is seen in order, to the left of D we have P and E. So P is already over, we have to write E. Then to the left of D we have H and R. Again KCF, C comes first, so C will be treated as the root node from A, and in order, to the left of C we have K, so K will be to the left of C and F will be to the right of C. Next is H and R. H and R, when I see it in pre-order, R comes first, so R is treated as written first, and to the left of R comes H in order. So this is how we construct a binary tree, and I hope you would have understood how to construct a binary tree on the basis of tree traversal techniques. Thank you.